Okay, welcome to our example logarithmic solving series, and this is example number 7. This particular question looks so familiar to me, and I think it's because there's one almost just like it on last year's college algebra final. I guarantee there was a problem of some sort where you had two different logs added together, same base, and of course it's just begging for you to use that multiplication rule. Which is exactly what you're going to do. You're going to combine this into a single log, and that's how you're going to go about solving this thing. So here we go. First thing we're going to do is say, well, if I got the log base 10 of x plus the log base 10 of x plus 3, that's obviously just going to turn into the log base 10, right? That's implied, of x times x plus 3. So x times x plus 3. And all that still is just equal to 1. Okay? So what do we do now? Well, this is the log base 10 of this is equal to 1. That means that 10 to the first power has to equal this thing. So we're gonna simply write it as an equivalent exponential equation. So it's very simply written as x times x plus 3 is equal to 10 to the first power. That's our 1 right there. Okay? So that's simple enough. We can distribute the x squared, x equals 10, because 10 to the first is just 10. We can subtract the 10. Now we have a quadratic set equal to 0. This one's a little bit easier. I don't need to use the quadratic formula because I can think of two numbers that multiply to negative 10 and add to 3. And those two numbers happen to be negative 2 and positive 5. So this is simply x minus 2 times x plus 5 equals 0, and that yields two solutions. X equals 2 or x equals negative 5. Now, you might have heard me talk in class about extraneous solutions, and this is one of those opportunities where you need to check. We've got two solutions. We need to make sure they're both absolutely workable solutions. So what we're going to do is we're going to plug both of these in our calculator, and we're going to see. And what you're going to find is when you put the 2 into your calculator, log base 10 of 2 plus the log base 10 of 5, you're going to find that that's the log base 10 of 10. You don't even have to put it in your calculator. You can just kind of do it by hand. And you know that's 1. So 2 is a perfectly good solution. Okay? Now, on the other hand, if you try to put negative 5 in here, you're going to be taking the log of negative 5. Okay? And there is no exponent that you can put on a 10 and get negative 5. So you get this domain error in your calculator or some other kind of error. So this one is false. Okay? Okay? It's what we call an extraneous solution. Because it sort of comes up in the solving and it seems like it ought to be okay, but it sort of like came along for the ride and snuck in there on us, and we need to double check. Okay? This is a good answer. This one just isn't going to work for us. That's number 7.